Good evening, everyone. Hello. Am I audible?
Evening, ma'am.
Very good. Okay. So, okay. So has everyone solved the activity questions, practice assignments? No one? Hello. I need answers. Has anyone solved the practice assignment questions or activity questions? So, do you know what sessions we are going to do today? Can anybody, one of you, like, can speak or something? Yeah. So today is a doubt sessions. If you Do you have any doubts today? Like you're not speaking. So do you have any doubts?
Ma'am, please solve the PYQ question.
PYQ questions will be solved at the time of the mock discussion. Today it's a doubt session week about week 4. If you have any doubts for week 4, just tell me.
Okay.
Yeah. So have you solved it or not?
Yes, ma'am. I am solved 4.1.
Only what your practice assignment or the activity
Practice
question?
assignment, activity question, all solved. Practice assignment 4.1 solved.
Okay, so there is no doubt like till that. Anyone else?
Ma'am, please give the example of biserial correlation coefficient.
Biserial code example like what? Uh, Numerical based.
Yes, ma'am.
Were you there in the live sessions, Santosh? Were you there in the live sessions that were held? Like,
Yes, ma'am.
yeah. So at that, like, so, uh, I taught you about the point biserial. So you had any doubt at that time?
No, ma'am. But I am solving some question then Problem, problem in those question, ma'am.
Yeah, what's the issue that you are having?
Okay, ma'am.
Hmm. No, I'm asking you, what is the issue that you're having? So maybe that thing I can clear to you, right? Nobody's having any doubts, right? Like, yeah, Nikki, which 4.2, practice assignment or activity question? Have you like calculated the correlation between them? Yeah, so just first calculate the correlation between them, and if you get like in negative, then it's a like you're talking about question three, right? Like we it's an MCQ. You're talking about that question, right? Yeah, so just first calculate the correlation and the values that you will get. Like if it's a negative, then you will tick mark the negative. If it's a positive, then it's positive. If it's zero, then it's no correlation like that. Okay, so if it's like close to my -1, then it's strong negative. If it's close to +1, then it's strongly positive, like that. So you have to first calculate the correlation, then you have to take the which the options which is correct. Fine. Is it fine, Nikki? Okay. Other than that, in the same assignment only, question number 8. Okay, the Simpson paradox. Okay, so let me tell you what is the Simpson paradox. Let me share you the screen. Are you able to see my screen? Yeah. So basically, if you see here, like this was the table that we had been given, right? This is the table of Captain A and Captain B. The matches are home matches, away matches, and home and away matches. Fine. Okay. Now, here we are calculating the win percentages and draw percentages and loss percentages. Fine. So win percentages for Captain A for home is 90%. For away, it is 53.52%. And the total, that is home plus away, it is 55.92%. Similarly, we calculated for Captain B, which is 75%, 41.66%, and total is 67.30%. Okay, this is the table. Now, if you see here, the winning percentage, like if you see overall here for home and away, it is showing that Captain A is having the highest winning percentage, right? Yeah. And if you see in Captain B, it's the lowest, that it's 75 and 41%. Okay. So basically, if you see separately in different groups, home and away, Captain A is having the higher winning percentage. But if you do, like if you see in the total area, total column, we see that Captain B is having the highest winning percentage. You getting my point? So this is the Simpson paradox. It is like in different groups, we are seeing like a different thing, and in total we are seeing another different thing, right? So like in a different group we saw that Captain A was having the highest winning percentage, but in total we are seeing that Captain B is having the highest winning percentage. Okay, so this is basically a Simpson paradox. Okay, so so similarly, we calculated for the loss percentage. So if we see here that like Captain A is having 10% loss, 45.77% loss, and in total 42.76% loss. Similarly, we calculated for Captain B. Okay, so if we see here for Captain B, the loss percentage is highest, right? But in total, we see that Captain A is having the highest loss percentage, right? So it is like since like it's a reversal thing in different groups we see that some other categories having the highest thing, but in total we are seeing that the opposite group is having the highest value. So that's a Simpson paradox, just the reversal, you can say that. Okay, so if you see the answers like C and D, like these are the yeah, these are the things. Yes, because the reversal of conclusion occurs in win percentage of both the captains, and occurs in the loss percentage of both the captains. Now you got it? You got it? What is the Simpson paradox? Fine. Okay then. Okay. Other than that, anyone else? Nobody's having any doubts? Like at least one of you say, if you are not having any doubts, let at least say yes or no, something.
Hello, can you hear me?
Yeah. Yes, I can hear you.
Sorry. I want that point by serial correlation thing which you described on the day with regard to the comparison of two different variables where we are doing. Could you please help me with the
Uh,
part?
you want me to repeat that thing again,
Yes,
right?
please. Yes, please.
Okay, just a second. Okay, can you see my screen?
Yes, yes, I can.
Okay. So like it's a data in which I am studying about the passing like the students are passing and the number of hours. I'm calculating the association between the number of hours they're studying and the passing and failing of that student. Okay.
Okay,
So this is the I'm denoting one as the students are getting passed and zero if they are getting failed. Okay. And these are the number of hours that they are studying. Fine.
okay. Yeah,
Okay.
yes.
Now, so point by serial is basically for what? It is for calculating between one categorical and one numerical variable.
Okay.
Yeah.
Yes,
It is represented by RPV.
yes.
So the formula is x bar naught minus x bar 1 divided by standard deviation of x into under root of p naught into p1. So basically what is x bar naught? See, here I'm denoting 0. 0 is one variable, one type of variable. Like this is a categorical variable. In that we have two parts, right? We have pass and we have fail. So one like x naught 0 is like it's denoting one part of the categorical variable. So I'm denoting 0 for the fail. Okay, so I'm counting x bar naught as the mean of the students who are getting failed. Okay, so the
Okay.
values are 4 plus 3 plus 5 divided by 3. Okay,
Yes,
so that's 4.
yes.
Similarly, x bar 1 is
Okay.
we are calculating the mean of the students who are getting pass.
Okay. Okay.
Okay, so that's
Yes.
8. And standard deviation of x, it's simply the standard deviation of these value that you can calculate, right? Summation of xi minus x bar square divided by n,
Okay.
right? So
Yes.
basically, this was some standard deviation. Then P naught and P1. P naught is basically the proportion. Okay, so
Okay.
P naught is what is the proportion of number of students who are getting failed? So it would be 3 by 6,
Yes.
right? Like
Yes.
out of the 6 students, 3 are getting failed.
Okay.
Similarly, P1 is the proportion of students who are getting passed.
Fine.
So it is out of 6, we have 3 students who are getting passed,
Yeah.
right?
40%. Yeah.
So just put all these value into this formula, then you will get the answer.
Okay, okay, okay. Thank you. And where this PSBB won't be working, the point by serial won't be working. I mean, where we cannot consider that this approach.
Yeah, like we will only consider when there is one categorical and one numerical variable is there. We
Okay,
can't calculate it for the two categoricals or two numericals.
okay,
It should
okay.
be one categorical and one
One
numerical.
numeric. Okay, okay. Thank you.
Yeah. Other than that,
Just,
any other doubt?
yes. I'm having. Just let me.
Okay, fine.
Yeah, you actually, when I was actually joining, you were discussing about the Simpson paradox,
Yeah,
and you were mentioning about where one of the is the Captain A is like looks like that Captain A is more weight compared to Cap, but the result will be different.
yeah, correct.
Did I understand right?
Yeah, yeah.
Okay, so but this will be the case every time, or is there an exception here?
This is like this is It's not like it depends. Like it depends upon the data and all. Actually, like if you see here, this is the Simpson paradox. Okay, so it is not necessary that in every questions we would be having the same thing.
Yeah, could you please actually help me with some other example where I can understand? Because I do understand this part, but whether
Mhm.
what the ambiguity that I am having is that because there are two captains here, things are different. Can you actually give some other example where I can understand better? If you don't mind.
Okay, you want another example. Okay,
Yes.
just a second.
Maybe could you please take the example of 4.2? Is that the right example? 4.2, question number 3.
Question number 3.
Sorry, question number 4, 5, 6, 7, 8. That is the Simpson paradox problem.
So this question only, na? You are seeing my screen, right?
Oh, yeah. Oh, yes, it's the same. Sorry.
Yeah. So should I take this example only?
Yes, please.
Okay, fine. Okay. So this was the table that we have been given, right? So there are captain A and captain B. We have total number of matches. And for home matches, we have this table. And for away, we have this table. And for both home and away, we have been given this table. Fine. These are the performances. Okay. Now the question is, I don't have to explain. Do I have to explain this question 4, 5, like, or only
No,
the
no. Oh,
simple?
the concept. I would like to have a conceptual thing here.
Okay,
Understand?
okay. So, like in Simpson paradox, like it's basically we are just calculating. Um, see, for firstly we have calculated the winning percentage here. Okay, for home it is 90%. For away it is 53.52%, and total is 55.92% for captain A. Okay. Similarly, we have calculated for captain B, home, away, and total. Fine. This is just we are just calculating the percentages. Now, uh, now if you look here, like just don't look at the total. We are just looking at different groups, okay, for home and away. So basically, if you see for home, it is like captain is having the highest percentage. Similarly, in away, we see that captain is having the highest percentage, right? Is it?
Yeah, because both in the case home and away, captain A has higher percentage. It 90 was a 75, 53 was a 41.
Yeah, correct. So,
Individually.
yeah, in individual case, in different groups, like for home is a different group, away is a different group, right?
Yeah.
So in different groups, we are seeing that captain A is having the highest winning percentage, right?
Okay.
But if we combine, we see that captain B is having the highest percentage. It's
Okay.
67, right?
Yeah.
So yeah, so basically, Simpson paradox, it appears like the trends that appear in different groups, like in home and away, reverses when the groups are combined. Okay, the trend that appears in different group gets reversed when the groups are getting combined. So if we see here, when it was in different groups, captain A was winning, but when we combined it, captain B was winning. So this is basically a Simpson paradox. Got my point?
If it because of the number of the what it call in case of let's say for example in case of captain A, there are
Hmm.
only 10 matches and for the home and for the away it's 142. Whereas in
Hmm.
case of captain B there is 200 matches,
Yeah.
and again here it is 62, 60. So
Hmm.
is it the numbers here is actually giving making the what do you call has a contribution here like I'm not getting understanding the part of the total thing where why the captain B is actually taking the edge compared to the captain B and what makes that difference there. Is it the number of matches? Let's say that both of them are playing 200 matches each.
Hmm.
But the winning part is, let's say in case of 200, instead of instead of 10, if it's 200, in case
Hmm.
of Captain A, if it is not in the same equal percentage, let's say the same 90% if we calculate there, again for 200, and in the case of same 53, if the number of matches is increasing, will there be a difference there because of the ratio of the total will change there?
I'm not getting your point.
No, no, because the number of matches that Captain B has in
Hmm.
home is 150 out of 200,
Ha, okay.
and case for A, so my question is my question is, if Captain A, let's say both
Hmm.
of them have the equal number of matches,
Okay.
because the percentage of winning is the home match and which contributes, but let's say that both of them have played the same number of matches, but the
Hmm.
winning is same, let's say the same 90.
Hmm.
There will the total will it reflect the Simpson paradox
No,
will
no,
change there
no, no.
if the total number of matches are
Then
same?
it won't affect, right?
Yeah.
Because we are having the same percentages. So in like if we see
No,
differently,
no, I'm not talking about same percentage. I'm talking about the number of matches. The same
hmm.
thing where you have 9 out of 10,
Hmm.
90%. If we think in terms of 200,
Hmm.
is it actually because the total when we talk about the total, there only the the whole thing is changing there. So if the number of total matches is equal, will it have something different? Because I didn't work out on this thing. I wanted to work on before discussing with you, but I couldn't work out on.
Like divided like what is the percentage that you will be getting? It depends upon that. Like uh 9 divided by if you're saying 200, it's like 0.004. So that means like 4.5%.
Yeah, that will be almost, it will become 50, 90, from 90%, it will go to 45%.
Yeah, basically.
Okay.
So it's actually a calculation base.
Oh, okay.
Yeah. So it's like we are seeing an overall, like we have just first converting it to and a percentage thing. Then we are
Mhm.
seeing in like we are observing things like in different groups, what are the winning thing, and in the combined form, what are the things?
Okay. Okay. Fine.
Fine?
Okay.
Yeah.
And where the I mean, in the real-time application, where the Simpson paradox will be applied?
Where this is applied. Oh, that I'm not sure. Let me just give me some time. I'll search about it and tell you.
Okay.
Yeah.
Okay. And in the eighth question, could you please explain that part only?
Which one?
In the eighth question about the multiple choice, yeah, that one.
Mm-hmm.
Could you actually explain this part?
Okay, so basically, like we have to, does the about data illustrate Simpson paradox? So we have to tell whether it's illustrating the Simpson paradox. So we know what is a Simpson paradox. Okay, so the first option is no, because the conclusion, aggregated and disaggregated cross extrapolations are the same. So if we like, uh, already we saw that it's showing the Simpson paradox. So this option is wrong, right? Then the second option is yes, because the reversal of conclusion occurs in draw percentage of both the captains. Okay, so if we see, we have here draw percentages. Okay, so if you see in different groups, we like there is no changes. Like all the values are same, right? Also in total, also we see that there is no changes. It's same actually, correct? The values is like 0, 0.7, 0%, 0%, 0.6, 0%, right? So there is no
Yeah.
changes here, like in different groups, also in the combined form. So we see that the reversal of conclusion is not occurring in the draw percentage. So this option is also wrong. So C option is yes, because the reversal of conclusion occurs in win percentage of both the captains. Reversal of conclusion means like in different groups, the trends that is appearing in different group is reversed when the groups are getting combined, right? So we have the reversal of conclusion. At first we were having some other conclusion, but it got reversed when we combined the groups. Fine. Similarly, we can see that there is a reversal of conclusion in loss percentage also of both the captains. Okay. So option C and D is the correct option.
Okay. Basically, the Simpson paradox is something that actually what we assume in the previous stages can it actually changes the at the end. Can I?
Correct.
Okay, thank you.
Okay.
So
Anybody else?
The Simpson paradox can be even applied for our classical coin toss problem also.
Simpson paradox.
Can be applied for this the classical coin toss problem, the head or tail problems also.
Head or tails? So
Yeah,
how? Like,
I'm asking
no,
because
it
normally
like, so see, you should have different things actually.
okay.
See, in this question that if we see here, we are
Uh-huh.
having different groups, right? Home and away. Then we are having combined thing, right? So we
Oh,
should have a situation like this in which we can have conclusion in like for like in individual groups. Then we should have another conclusion by combining those groups. So we should have that kind of situation.
so so if so it more than two component here, two elements to be considered here, or I don't know what is the right term to use here. Uh, more than three possibilities, more than two possibilities like that.
Okay, so basically, if you see, like in okay, so like for in medical studies, okay, so like if we are like if we are testing about a new drug, okay, so overall it would appear that like if we are testing overall, then we say that it is effective, okay. But if we broke down, if we like we go by age group, by different young, then we have older, yet younger generation, and we have older generation.
Oh,
If we break down that age group, okay, so
okay.
we see that in like that drug is less effective for the younger ones and for the older patients, but it is more effective for the middle one. You
Okay.
are understanding my point?
Uh, so you are referring to the efficacy of the drug that is there, which changes
Yeah,
according to the group
yeah, correct.
based on that.
So like at first we saw it overall, in overall it is like it is effective. But
Oh,
if we break down, if we like subgroup the parts, okay, if we break
oh,
down by age group, we see that it is less effective for the younger ones and the older ones. That's it.
okay.
So yeah, so in overall we see that the conclusion is different, but if we break down the things, we get to know more about it, right?
Okay, so this is like it sounds it is like the holism concept. The sum is more than the parts, or how should I consider here?
Yeah, you can consider it like overall we are seeing a different conclusion, but if we look carefully, if we divide the groups and all,
Uh-huh.
right, then
Okay,
we see things more clearly.
okay, okay,
Yeah, so we can see here the younger and older one is having the less effective, so we would be trying out new drugs, and also that the younger ones and the older ones should also be having a more effective like they should also have a more effective thing for the new drugs, right?
okay, okay,
Yeah, like that.
okay, okay, fine. I understand. Thank
Hmm.
you.
Okay. Okay, anybody else? Anybody having any other doubts?
Ma'am, can we say that Simpson's paradox can only take effect if there is a large difference in the sample size?
large difference in the sample size.
Because the only way the percentages can be different is, I'd say if it were the same sample size, then a less percentage would mean a less overall percentage as well. If there's
Hmm.
a huge difference in sample size, then the number of people in totality would create a bigger difference.
Maybe I think so.
No, ma'am. If we'll increase the size, the win ratio also will increase according to it. The percentage will be remain same. The number may different.
So you're saying that if we increase the sample or if we take both of the samples same, then we won't be having, yeah, then of course, yes. So like if the samples are same, then we won't be having any conclusion, right? We won't be having any Simpson paradox there. If we having different samples, then of course we would be having Simpson, like we would be having different percentages, then we would be having like Simpson paradox can be applied there. Is it clear or
Yes, ma'am.
yeah?
Please help me to understand
No, ma'am. I have
about
doubt.
correlation.
Sorry?
Ma'am, if we take the size of sample same,
about us.
One second. Yeah, who is speaking? Yeah, just one of you speak, please.
Tushar, go
Yeah.
ahead.
yeah, ma'am. Ma'am, if we take the size of sample same, like at home captain A and B plays 200 matches each. So you are saying that the paradox will not be happen here, right?
Yeah, just calculate it, right? So if you divide 9 by 100, it's showing like 4.5%, then
But it is still if we they will play 200 matches each. That means captain A will win 180 games, so it will remain 90% only. So I think it doesn't matter how large or small the side sample is.
you are saying that it is remaining 90% only.
Yeah, convert it if he's playing 200 matches at home captain A. So
Hmm.
that will mean one captain A will win 180 matches. So the percentage will remain same. That is 90%.
But that's if he actually has played 200 matches and won 180.
Yeah.
Yeah, like that. Correct.
So it
So,
remains
yeah,
unchanged. The
if it is,
percentage will
yeah,
remain same.
the thing is that the values here matters actually,
We are
right?
saying a
So,
percentage is not the numbers that they have played or won.
yeah, that's the thing. Like, so the percentage that we have calculated, we are just from that percentages only, we are getting that conclusions, right? Not from
So,
the numbers.
so this means that size of sample that doesn't affect anything. It
Sam.
could be the captain. He can play only 5 matches. It doesn't matter. It will still remain same 90% only.
Hmm.
But we
Correct.
can't exactly say that if Captain A plays 200 matches in the future, he will have won 180. He may win 130, he may win 120.
That is probability, but from the data, we can say if we'll convert 10 matches into 200 matches from the data we have, the percentage will remain same.
But we can't because the sample size will remain the same. If we've taken 10 matches as a sample, it will remain 10 samples. You cannot change it to 200.
Why
No,
not?
he's just
Why
You were,
not?
no, how can you change it to 200 sound?
Ma'am, I have the percentage that I will win 90%. Ma'am, I am sure that if I'll play 10 matches, I'll win 9 matches. So I can confidently say if I'll play 1,000 matches, I will win 900 matches. I have the percentage. We are not working on the probability here. We are working on the stats. There is possibility in 1,000 matches he will win only 9 matches, but from the data here we can conclude that
Here
he
we are
will win
just
900
calculating
matches.
these are the relative frequencies, right? This 9 by 10, 76 by 142. These are some, uh, the relative frequencies, right?
Yeah.
Yeah, correct. So, so the relative frequencies are basically the proportion, right? So, like we are just calculating the proportion of the winning percentage of Captain A for home.
So, what will the outcome, ma'am? Will the sample size affect the paradox or not?
Just give me 1 minute. Let me think about it. Okay. Anybody having any other question other than this?
I have a doubt. I mean, I would like to you discuss about correlation and association on the day. Uh, I would like could you please uh, give a glimpse about that same about the correlation and association.
Can you repeat? I think your voice is breaking.
I'm sorry. Could you hear me now?
Yeah.
Okay, you discuss about correlation and
Hmm.
association on the day. Could you
Hmm.
please repeat that? Could you please give a brief about that, about correlation and association?
Correlation association.
Yes.
You're talking about correlation only, right?
Yeah, because on the day you actually initially you are discussing about correlation. Later at the end you are also discussing about association, right? On the live session on the previous day.
No, no. If you are calculating the association between two numerical variables, then if we want to calculate numerically, we calculate the correlation value.
Okay.
Yeah, that's the thing. If we are talking about the association between two numerical variables, then we calculate the correlation between them. But with that correlation thing, we will we will get to know the strength and the direction of the association between the two variables. Got my point?
Okay. 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 Yeah. Oh, good.
Yeah.
Okay. Fine. Thank you.
Okay then. Anyone else?
Hello, ma'am.
Hello.
Sorry, ma'am, to ask this, but I just joined the session. What are we discussing?
It's basically a doubt session. So if you're having any doubts in week 4, you can
Okay,
ask.
no. I am asking about these questions. Question.
Which the Simpson paradox?
Yes, ma'am.
Basically, I'm just I'm explaining what is a Simpson paradox actually.
Ma'am, it is basically the finding the hidden trends na in the given data.
Yeah, in the subgroups actually.
Okay.
Yeah.
Ma'am, can we ask week 5 doubt?
week 5.
Yes, ma'am.
But week 5 sessions have not been yet started. So, okay, just let me complete this week 4, then we will come back to that. Yeah.
And I didn't understand this thing. The lecture also, I was trying to see the association between this two numerical variables and putting a line.
Can you speak louder?
The association in the lecture thing, association between two numerical variables and putting a line. I didn't get that properly. Maybe I'm not getting it clearly, or I'm not sure about that. But
You're talking about equation of line?
yeah, but the equation of line, the fitting. I was wondering what is that fitting a line thing here? I didn't get this concept there.
Fitting of line in the sense that we like if you see in the what say like this was the thing, right? So this is the thing. So we are just like this was the data that we have been given. This is a scatter plot, right? So we are just let's say we are just fitting a line in this data. Like this line is representing the whole data. Like if there is if there is variability between the explanatory variable and the response variable, like that. So this line is actually showing the, like it's actually a you can say in words.
Oh, is it? Are we connecting the dots here?
We are not connecting the dots. No, no, no.
Because when I understood, I thought like putting a line is basically we are trying to connect the dots here. And
No, no, we are not connecting the dots. We are just making a dot. Uh, like basically,
But these
like
data, these
we are
dots represent the data we collected or what?
sorry.
And these dots that we are on the graph, these represent the data we have collected
Yeah, these are the
or
points that
anything
we
else.
have collected. Yeah, it's like just don't go into that deep. It's just some points that like it's an example. Okay, so basically, this is like if this is my graph. So like if this is my graph here, so these are my points. Okay, so I have to fit a line which is representing this thing. Okay, so I will make a trend line here.
but what is the criteria for drawing that line?
You don't have to, like if you like it's a like in Excel if you do it,
Uh-huh.
yeah, so it will basically fit a line into this, which is like if you see the lines, these are near to the like near the data points, right? So this like we can this linear association can be described on the basis of an equation of line. That's the thing. So this is like we are just representing the association um using an equation of line. That's it. Like we are just describing the association using an equation of line. So this equation of line is basically in the form of y equals to mx plus c, right?
The
So
slope thing.
yeah, so here like if I'm getting the equation of line as y is equals to minus 0.694 into x plus 9.03, right? So this is basically a slope and it is negative. So we see that there is a negative correlation, like the slope is negative. That means if my values of x is increasing, my values of y is decreasing. So that's the association. Like if like there is a negative association between them. If one value is increasing, the other value is getting decreased, right? So on like with the help of equation of line also we can like describe a linear association between them. That's the thing. Okay, so and like if you want to see whether this line is the best fit line, right, which is like if it is the best line which is describing this association, so we calculate the r square here. Okay, so r square is between 0 and 1. So if it is near to 1, we see that like if it's equal to 1, this is equal to, okay, so if this is equal to 1 or near to 1, we say that the line is the best fit line. Okay, if it's 0, then that means like the line is not a best fit line.
Okay.
Got my point?
Yeah.
Yeah, that's it.
But this line that we actually draw, I mean, how do you judge that the line can be in this way only?
No, you don't have to draw, but like through softwares and like in Excel sheets and all, like through Python and all. Yeah, so you don't have to draw it yourself. Like in Excel sheet, there is like if you have seen the lectures and all, you can like when you draw a scatter plot and all, there is an option for trend line. So it basically like if you click on that trend line, it automatically creates a line. It fits a line.
So that line actually won't touch any of the data points.
It won't touch. It is just showing you the trend line, how the trend is going.
Basically, can I say it's
It is
traversing between the two data points?
No, it will be in the most proximity of the data points.
Okay, thank you.
yeah. Is it clear or?
No, I want because I do understand that this actually is based on it, but want to know. I mean, my doubt is whether it's not touching or it's because if the then in the case the two data points are there is no what you call there won't be any proper coordinates because I understand the points that we plot it should be based on the coordinates. Am I right? With related to price and age. Which
No,
point?
see, this line is not it is not actually touching the points and all. It is just showing you a trend line, or you can say that this line is uh, how can you say that? Like we are just representing these this dots into a in a line. You can say like that.
In a linear fashion, or can I say that
What?
in a linear way?
In a linear way. Yeah, through an equation of line. That's it.
Thank you.
Yeah.
Ma'am, excuse me.
Hmm.
I understood how to calculate the correlation coefficient, but how do you calculate the R square?
You are talking about this R square.
Yes, ma'am, the 0.85.
Like if you calculate the correlation and you just square it up, you will get the R square. But actually, you don't have like in quizzes and like in exam, you like we won't be asking you to calculate the R square and all.
Okay, ma'am, it's just the correlation coefficient.
Yeah, we will be just asking you about the correlation coefficient.
Okay, ma'am, thank you.
It's just that you should know what is an R square. That's
Okay, ma'am, it's the square of the correlation coefficient.
yeah, you can say that.
Okay.
Okay. Other than that, that's it. Like,
I mean, we will get the practice assignment solutions, am I right? Because I have doubts with practice assignment 4.1.
you want the solutions.
No, I think we will be getting it. So I want to know about this problems 3 and 4.
Okay. You're asking about practice assignment 4.1. This one.
Yes, that's okay.
Have you seen the solution here?
No, that's what I'm trying to understand it, but I'll go
Okay.
through the whole thing because
Question number 2, right?
that's question number 3 and 4. Am I right?
Okay. Sorry. Question number 3. Okay. What can be said about the correlation? Okay, so y, where x takes the values of the first 10 positive integers. So this is the relation between y and x. Okay, y is represented as x square plus 8x plus 16, and x is the first 10 positive integers. So first of all, we have made a table here. X is taking all the 10 values, and we, with like putting the values of x here, we are getting the values of y. Right? So is this table clear now? Is this table clear? This one, x and y. How we got it? So if we put the value of 1 here, we will get the value of y as 25. Similarly, if we put the value of 2, we will get as 36, like that. So we have made a table of x and y here. So we have to calculate the correlation coefficient between x and y, right? So what is the formula of correlation? Which is summation of xi minus x bar yi minus y bar divided by standard deviation of x and standard deviation of y, correct? Are you there?
Yeah, sorry, I'm here.
Yeah. So
I'm here. Sorry.
yeah. So this table is clear to you? This one? Yeah. Okay. Now, like for the xi's, see, so the xi's are this. So we have calculated xi minus x bar. So first of all, x bar is the mean of the x variable. So we have calculated it. It is 5.5. Okay. So we have calculated xi minus x bar, and we have calculated xi minus x bar whole square. Okay. Then we have calculated the standard deviation of x. Similarly, for the y variable, we have calculated yi minus y bar, yi minus y bar square. Then we have calculated the standard deviation of pi. Okay, these are the denominator part. Then in the numerator, it is summation of xi minus x bar, yi minus y bar. So these are the values. So we will sum it up, okay, which is going to be 1567.5. Okay. Yeah. Then putting this value like 1567.5 divided by the standard deviation of x into standard deviation of y, we will get the correlation. So basically, in this question, we
This
are
is the R
not
value
giving,
that
sorry.
This is the R value that you are in the previous problem you are talking about.
Yeah, this question
R
number,
value.
yeah, we have calculated the R. But in this, like, we have not been given the table. Like, what are the values that X is taking? What are the values of Y taking? So first of all, in this question, we made the table, then we calculated the correlation coefficient.
Okay. Okay. Thank you. Yeah.
Yeah.
I had doubt, like, will we have sufficient time to do such amount of problem there?
No,
in
no,
the
you
exam?
won't be like you won't be getting that this type of questions, like lengthy questions. It would be like the questions would be made, which can be done in like in that time. So don't worry about that. Okay.
Okay.
Yeah. So like question 4 also.
Yeah.
pairs, B and D are having the same. Okay, so we have to calculate the sample correlation coefficient for the data pairs A plus Bxi and C plus Dy, where B and the sign of B and D are same. Okay, so first of all, we are considering that the sample correlation coefficient for the data pairs this are R dash. Fine. So we are considering that B and D are positive. The signs are positive. Both of the signs are positive. Okay. So the mean of the data pairs xi and yi would be x bar and y bar, and standard deviation would be sx and sy. Okay. Now for the data pairs a plus bxi, c plus dy would be a plus bx bar plus comma c plus dy bar. The mean would be like we are just adding and multiplying the constant term, right? So this would be the mean only,
Yes.
correct? And the standard deviation would be b into standard deviation of x comma d into standard deviation of y, because if we add or subtract any constant, it won't matter, right? If you remember,
Yes.
correct? So this would be
Yeah.
my standard deviation and this would be my mean. Fine.
Okay.
Okay. So if you just like we have got the mean, we have got the standard deviation. So if you put these values in the formula, so it is basically summation of um x. So it would be, so if you solve this, just a second. So basically this was my pair, right? And this was my mean of that, correct?
Yes. Yes.
Really? This would be C plus dy, right? C plus dy I minus C minus dy bar. Okay. Divided by the standard deviation of x and standard deviation of y, correct? So this would be like here A and A will get cancelled. Here C and C will get cancelled. So this would be summation of like B would like B is common, right? So we will take it B common. So it would be xi minus x bar. And here D is common. So this would be D into yi minus y bar. Fine. Divided by the standard deviation of x and standard deviation of y. So this would be summation of bd xi minus x bar yi minus y bar divided by the standard deviation of x and standard deviation of y.
Why?
Correct?
Okay.
So we have to calculate the sample correlation coefficient. Here, this would be, see, here the standard deviation of x was bx. This was the standard deviation, right? Not this one. And dsy, correct? Like see, the mean for a plus bxi, the mean was a plus bxi bar, correct? Similarly, the what was the standard deviation? It would be b standard deviation of x, right? So here the standard deviation of x would be bxi, and for y would be dsy.
Yes.
Are you getting my point?
Yeah, I'm getting it.
Yeah.
Kindly bear with me, but my internet is quite unstable, so I'm getting a time lag in your voice. Sorry.
Okay, so you are hearing it correctly. My voice is clear, right, to you?
Yeah. There is a bit of time lag, so I'm not able to respond
Okay, it's
immediately.
fine.
I'm sorry.
So here B and D would get cancelled. So we would be getting summation of xi minus x bar yi minus y bar divided by standard deviation of x and standard deviation of y. And this is particularly our correlation coefficient. So my r dash is, so that's we say that r dash is equal to r, right? That means my like my correlation sample correlation coefficient is equal to my correlation coefficient. Okay.
Okay, so both are
Yeah.
the same.
So that's the thing.
Okay.
So here we are getting when they had the positive sign. So we got that the sample correlation coefficient is equal to the correlation coefficient. Similarly, we take another case in which B and D are negative. So if both are negative, like we are having the products, like if you see in the solution, it was B into D, right? So if we are having the products, so it will be positive only. So then also we would be getting R dash equals to R. So option C is correct. That means my uh, the sample correlation coefficient would be equal to R only. Okay,
Equal to the correlation.
got it?
Yeah. So,
Anybody else? Okay, Tushar, your doubt about that. Let me just like do some like I need some time to think about it. Then we will, like, tomorrow we are having the revision sessions and all, right?
Yes,
So
ma'am.
yeah, I will clear you on like tomorrow. Fine.
Okay. Thank you.
Okay. So okay. Other than this, anybody having any other doubts? If nobody's having any other doubts, can we close the meeting? Shall we close it then?
Yeah, we can wind it up.
Okay then.
thank you.
Okay. Thank you, everyone.
Thank you,
Thank
ma'am.
you.
Thank you.
Ma'am, I have a doubt. Are you there?
Sorry.
I have a doubt in this question.
Yeah. What's your doubt?
Ma'am, may your practice assignment EMQ?
Practice assignment EMQ.
Yes, ma'am.
Uh, EMQ 1, 2, which,
Not the graded one.
uh, what's your doubt in that?
In ma'am, question number 7, given option number. Can you just explain question number 7?
Like there are, which
Correlation coefficient between X and Y.
EMQ you are talking about? There are like three. So which one?
Third one.
Third one. Okay. Question number 7. Asking, right?
Right.
given list of options, select the option.
Correlation coefficient.
Excel one. So it is basically saying that our explanatory variable, the values of explanatory variable is high and the corresponding values of the response variable is low. That means like if my values of X is increasing, my value of Y is decreasing. That means it's a negative correlation.
Mm-hmm.
Correct? So, um, so there should be like it's a negative correlation that is option 15. Correct?
Mm.
Yeah.
But we have to find correlation, right?
Don't have to find from the given list of options, select the option numbers which represent the nature of correlation coefficient. We have to find out the nature of correlation, whether it's a strong correlation, whether it's a moderate, which is it's a weak, positive, negative, that we have to find out. Okay?
Okay.
Yeah.
We have to submit this file after in this folder. We have
Yeah.
given other like code and debug,
Yeah,
test run, submit.
there is one instruction like how to EMQ, right? Yeah, just watch that, then you will get to know how to do it. Right?
On portal only.
Yeah, in the portal only.
Okay, I'll see. Thank you, ma'am.
Yeah. Has everyone watched the Solve with Us session for week 1 to 4?
Week 4 is remaining rest complete.
Sorry?
Week 4 is remaining rest is complete.
Okay.
Completed week 4.
Okay then. Okay then. Yeah. I think this was the last out, so we can end it up.
Yes, ma'am. Thank you.
Okay. Thank you,
Yes,
everyone.
ma'am. Thank you, ma'am.
Yeah. Okay. You can leave the meet.
Hello. Hello. Am I audible? Hello. Hello. Hello.
Hello? Hello? Am I audible? Hello?